All right. This is Energized electrical work relative to OSHA and NFPA 70E, presented by Brandon Walton, aka Barbara. To get it started off, we're going to go over a few key terms that you may need to know during this, which is arc flash, an extremely high temperature discharge produced by an electrical fault in the air. Arc flash boundary, which is the distance from exposed energized conductors or circuit parts where bare skin would receive second-degree burns. That is equivalent to 1.2 cal centimeter squared. And then we have arc flash hazard analysis and arc flash risk assessment. So the analysis is a study used to prevent injury by determining potential electrical arc flash hazards. The arc flash boundary is the incident energy exposed at working distances in the required PPE and arc rated protective clothing. And then arc rating is the incident energy in cal centimeter squared on clothing that has a 50% probability of resulting in a second-degree burn on bare skin, underneath clothing, or material break open. These next few key terms are pretty important later on. So, Energized electrical work permit, a document that describes the job planning needed to perform energized electrical work safely. And then energized work is obviously work on or near exposed energized conductors or circuit parts where a person is exposed to electrical hazards. Hazard risk analysis is the evaluation of all hazards that may be present, as well as an assessment of the possible risk factors that may exist. And then incident energy is a measurement of thermal energy, cal centimeter squared, at a working distance from an arc fault. Last two terms that I think were important are limited approach boundary, which is the distance from an exposed energized circuit or circuit part at which a person can get an electrical shock and is the closest distance an unqualified person can approach. Restricted approach boundary, the distance from an exposed energized conductor or circuit part where an increased risk of electrical shock exists due to the close proximity of the person to the energized conductor or circuit parts. And we will get into all of these terms more in depth here soon. So, justifying energized work according to OSHA and the NFPA 70E. There's really only 3 points to justify working on something hot. And that is if there's a greater risk created by de-energizing the conductors or circuit parts, like a life support system or emergency alarm system, or, lighting from an exit, stuff like that. It's more important to have it on than it would be to have it off. And then if it is infeasible to de-energize the conductors and devices, which is due to equipment design, or if electrical testing must be performed with an energized circuit due to the importance of the equipment's operation, like HVAC system and a chemical processing plant where, you need that HVAC system to be filtering the air in there because it could be toxic or something like that. And then lastly is if the energized conductors or circuits is less than 50 volts, and there would be no increased exposure to electrical burns or arc flash. And also, if it's under 50 volts, you don't need to be licensed to work on it anyways. All right, energized electrical work permit. We're going to get into what it is and what all is included in it. So according to the NFPA 70E, an energized electrical work permit is required to perform energized electrical work. So what the energized electrical work permit consists of is a description of the equipment or circuits that are to be worked on and where they are located. Justification for the energized work, as in why you need to work on it hot. And then the safe work practices to be used while performing the task. Results of an electrical hazard analysis, including shark and arc flash. Required limited, restricted, and arc flash boundaries, as well as the nominal voltages of the circuit and the incident energy available at working distances. And all that stuff we're going to get into later on in this presentation. PPE required to do tasks safely. Steps used to restrict unqualified or unauthorized personnel from entering work zone. Evidence of a completed job briefing by completing a job briefing and planning form, and then signatures of everyone involved or affected by the work. All right, so energized work versus troubleshooting. OSHA and NFPA 70E do not specifically explain the difference between the two, but other than typically if a person has a tool in hand, it is considered energized electrical work and would need a permit. But if the person has a testing instrument in hand, it's considered troubleshooting and a permit is not needed. Clearance and approach distances. Both OSHA and NFPA 70E require that a qualified person must be trained in and familiar with clearance and approach distances with regards to energized electrical systems, as well as corresponding nominal voltages that will be exposed to. So what it basically means is you need to have training and be trained by someone who is qualified to teach you in working on the live parts and the distances and so on and so forth. And in this chart, it gives you the limited approach boundaries for a movable conductor, and then limited approach boundaries for a fixed circuit part, and also the restricted approach boundary. I'm not going to read all of them, but we'll do one of them. So we'll do 50 volts to 300 volts. So the limited approach boundary for a movable conductor is 3 meters or 10 feet away. The limited approach boundary exposed for a fixed circuit part is 1 meter or 3 feet 6 inches. And then the restricted approach boundary for that is 0.3 meters, which is 1 foot. Actually, I lied. It is actually avoid contact. Sorry, it was a little hard to read. All right, so what is approach boundaries? And what all the different approach boundaries are on this slide. It said a limited approach boundary is the distance from an exposed energized conductor or circuit part at which a person can get an electrical shock, and is the closest distance an unqualified person can approach. So just to reiterate that definition so that we can break it down a little more. So the limited space is the area between the limited approach boundary and the restricted approach boundary where unqualified personnel are allowed in, but they must be advised of the specific hazards and are continuously escorted by qualified personnel. You also must wear the proper PPE to be in the limited space. The restricted approach boundary, the distance from an exposed energized conductor or circuit part where an increased risk of electrical shock exists due to the close proximity of those to the energized conductors or circuit parts. Restricted space is the area between the restricted approach boundary and the prohibited approach boundary. Only qualified personnel are allowed in this area, and so the circuit or equipment must be insulated for the voltage inside the restricted approach boundary. You also have to wear the PPE. PPE must be worn and be appropriate for the voltage, or a person is insulated from the voltage by insulated bucket truck or other means. And then here's another table that shows you line work and for AC live line work, and it's your approach distances. I'm not going to do them all, but we will do, this is also the nominal voltage over here to the left is in kilovolts, and phase to phase. So we'll do the 1.1 to 15 kilovolts, and it says the phase to ground exposure, you should be 2 foot 1 inches away, and then the phase to phase exposure, you should be 2 foot 2 inches away. And then down here on the bottom, right there, is the approach distance for qualified personnel, alternating current. So the voltage range is, we'll do 300 volts and less because it's typically what I work with. And it is minimum approach distance is to avoid contact. So if you go over 300 volts but not over 750 volts, the approach distances for qualified personnel is only 1 foot. So it's pretty small. All right, and now we're going to get into arc flash hazard analysis and arc flash boundaries. So the arc flash boundaries must be established to complete an arc flash hazard analysis. These help determine the proper PPE needed for a task, the risk and hazards involved in the task, and then changes need to be made to the arc flash hazard analysis whenever there is a major modification or renovation to an electrical system. And it says NFPA 70E Article 130.5D and NFPA National Electric Code Article 110.16 identifies the requirement for labeling of equipment with regards to arc flash hazard. The label will show available incident energy and corresponding working distances, minimum arc rating for clothing, required level of PPE or highest hazard/risk category for the equipment, the nominal voltage, and the arc flash boundaries. And then on the next slide is an example of that warning label. You got arc flash and shock hazard appropriate PPE required. You got 126-inch arc flash boundary. You've got 4.06 cal centimeter squared flash hazard at 36 inches. So your arc rated clothing needs to be cotton underwear and AR shirt and pants, minimum arc rating of 8 cal centimeter squared. And then class 2 gloves, and then 13,800 vac shock hazard when cover is removed. So this next slide is choosing the proper PPE, and I guess I should just break it down a little bit by little bit. So class 1 is 4 cal centimeter squared, and then class 2 goes 8 and less cal centimeter squared, and then the class 3 is 25 cal centimeter squared and below, and then class 4 is 40 cal centimeter squared and below. So class 1 is like a arc rated long sleeve shirt, arc rated long pants or overalls, hard hat with arc rated face shield, safety glasses, hearing protection, leather and voltage rated gloves as needed, and leather work shoes. That's just one of the classes. I'm not going to read all of them. And then this is the chart for the proper PPE gloves. We'll just read the red one, which is the second one, and it says proof test voltage. It went from 5,000 to 20,000 volts, or actually it's 5,000 AC and then 20,000 DC. And the max use voltage AC is 1,000 and the DC is 1,500. Rubber molded products label, it has a red label on it, and then the insulated rubber glove label is also red with a 10 on it. And then you also see the red label right there, dipped sleeve label as well. And then the PPE inspection. PPE should be visually inspected before every use. Rubber insulated gloves should be electrically tested every 6 months, as well as the visual test every day before use. And then rubber mats and blankets should be tested every 12 months. And hard hats need to be changed every 5 years from manufacture date. Arc flash clothing should fit loosely but not too big to cause trip hazards. And then we're going to get into troubleshooting and PPE. So the troubleshooting circuits of 120 volts and below doesn't require arc flash clothing, but does require rubber insulated gloves and leather protection when necessary. And troubleshooting 240 volt and less is arc rated clothing of 4 cal centimeter squared. Also a face shield of the same requirements or rated hood of the same requirements. And you need a class E or G hard hat, a UV rated safety glasses, hearing protection, arc rated gloves, or class 0 or class 00, or OT shall I say, or double OT rubber insulated gloves and leather protectors. Leather work shoes are also needed. And here's the big boy, troubleshooting 240 volts up to 600 volts. So the limited approach boundary is 48 inches. The restricted approach boundary of that is 12 inches. Arc flash clothing system needs to be at least 8 cal centimeter squared or above. Arc rated face shields or hoods rated at 8 cal centimeter squared or above. Class E or G hard hat. Arc rated hard hat liner, UV rated safety glasses, ear protection, and then arc rated gloves of class OT or double OT rubber insulated gloves with leather protections. And then heavy-duty leather work shoes are required. And in summary, working on or near energized electrical systems is one of the most hazardous tasks that an electrician can perform, obviously. So failure to follow safety guidelines can and will result in injury or death. Always work on de-energized circuits or conductors when possible. If not possible, follow the steps and guidelines laid out in this presentation. And there's my sources. I literally just used our school book for everything. So, hope you enjoyed it. I had fun with it, and this is Barbara signing out.